It's time to learn about cross-validation. Let's start with the general concept of testing machine learning models. Okay, testing a machine learning model on the training set, as we have seen, is problematic. Strong models like decision trees easily overfit the data, and then you can get these perfect scores like, oh, I got a 1.0, perfect, move on. No, because your model like generalizes poorly to new data. That's the point. This is all about making real world predictions. It is not curve fitting. Okay, so as mentioned, predictions on data, it's bad when it's overfitting. Okay, so splitting the data into a training and a test set is better, okay, and that's what we've been doing, but different test sets can lead to very different scores, even though you have the same model, okay, you have the same kind of machine learning model that you're using. Okay, so this is the issue that we are now going to address, and cross-validation is the solution. So what is this? Cross-validation splits the data multiple times into training and test sets. Okay, if each time you split the data, you're going to get a new score. Okay, that's the whole point of it. So you get multiple scores using multiple test sets. The splits rotate, by the way, so that all segments of the data are used at some point as the test set. And so if you isolate, say, the middle 20 rows as the test set, then the remaining is what it's trained on. And this is nice because it's sort of, because you're testing on every part of the data, things balance out. You use the average score of all splits then, right? Because you're going to get multiple scores, like 5 different scores. And this average score is going to be a better indicator of how well the model will perform making predictions in reality. The goal here is not to get necessarily a better score, okay? Cross-validation is not going to give you a better score. It is going to take the mean of 5 different scores, or more or less. 3 splits, 5 splits, 10 splits, 20. Those are the, the most common ones I see. It depends on the size of the data. Technically, you could have any number of splits. Okay. This is much easier explained with this image. Really nice image here. This is taken from Wikipedia. So you have an example, okay, of what we do. Okay, here you have your test data, and here you have your training data. Now, we've done this over and over again, where we get a score, we train the model on the training data, and we score it on the test data, right? That's what we've been doing. But in cross-validation, in this particular image, you see it's going to do this 4 different times. You specify how many times it does it, and it's going to give you a different score, okay, 4 different scores. But note that in each particular iteration, like look at the third one, you're getting a score, you're getting predictions from a different part of the data, a different test data that the model, you could say, has not seen previously. Now, there is overlap with the training data. Okay, it has to be that way. But the point here is you simply rotate among the test scores and you get a much better indicator of how your model is performing in reality. So once you have cross-validation, that's what you use, okay? Validate means you're sort of validating the model, okay? You're getting a bunch of different test scores to validate that you have a good model. If you don't get good test scores, maybe you use a different model. Okay, so this is the idea of cross-validation. Really nice visual. If your data set has, what might it have? It could have any number of rows, right? If it has like 1,000 rows and you do 4 test sets, well, each time it's going to train on 750 rows and test on the other 250 if you specify 4. The default is 5. You could go lower or higher. There's not a right or wrong. The point is you want to use cross-validation because when you get a score, okay, of how well it's doing, you've averaged out multiple test scores, and that's about as good as you can do.